Okay, so where did we leave? I actually don't want this. Yeah, last time the question that I didn't understand was how to do like write an language program to add two binary coded decimal numbers stored at locations something something. Okay, and place the binary coded result in location 3502H and onward, starting with LSB. LSB means lowest significant bit. Right, so 3502, it has the sorry lowest significant byte. So 3502, that has the lowest significant byte, and the next one has the higher one, so it's like all the carries accounted together. Right, and yeah, so the solution that they gave is something like this. So just type that out. Come on guys, this is not working. Okay, so this is the solution. So they said, first of all, LXI H with 3500. So they are loading 3500 into our what do we call it, our HL pair, right? And then you also need 35001. Then you're moving, so MBI D00. So they're moving 00H into, should be H over here. So they are setting D register as 0 basically. Then they are doing MOV A comma M. So they are moving from memory to accumulator. So whatever the number was in 3500H, they just moved to accumulator. Then they are incrementing H. So now you will be having 35001 in there. All right. Then they are doing A double D M. So add M. So to the accumulator, now they are adding this thing. It's still weird why this should even work, because this is in binary coded numbers, like each label represents that. So how would it even work? I have no idea. Right. Okay, then after that they said EAA. So this is a decimal adjust. Right, so what is this? Yeah, decimal adjust ACC. That means decimal adjust accumulator. What this thing does is that it takes the content in the accumulator and it converts it to the binary coded decimal format. So basically, what actually they did is that they treated the numbers in 3500 and 3500 as if they are not binary coded, but instead they are just normal hexadecimal numbers, and then they add them up and then they convert it to binary coded decimal numbers, which is yeah, like, no, this is not cool, man. I thought that these were binary coded, and that would make this so much more complicated, and you're just assuming they're not. So it's unfair, kind of, but yeah. Let's see what they did next. So DAA, that is decimal adjust accumulator, and then JNC, so jump on not carry. So if we are not carrying, then they just jump to a label they call loop, and so if you have carry, then you increment D. So D is containing all the carries. Well, actually, it's a nice thing. I could have also used this in that question where they asked me to sum some stuff, right? They asked me to sum all the contents in addresses 2001, 2002, and so on, right? And till a certain point, and then some all of them write the lowest significant bit in 2500, and from that onwards write all the higher significant bits. And I didn't actually write all the higher significant bits, so I should have done that, but like it was kind of new for me that, yeah, I generally don't write a lot of these kind of programs because, yeah, like I only came in contact with this thing before I started actually understanding C++. And it was a kind of new thing to me. Still not very clear how this works in depth. Like, but at least now I understand how a computer works. Like that's a nice thing, I think. So I understand C++ at a greater level in that case. And hopefully all other programming languages too. So this really did help in understanding a lot of things. Right? It was like very insightful, but I have I have like zero practice in this actually. So that's why I'm doing this. It's called practice. Okay, so jump if not carry to loop, and if it is carry then increment d, and our loop thing, that is increment h. Right. So in both the cases, they just jump to this thing. But in the case where you had carry, you would increment D. So it should be capital H. But like it's not case sensitive, so whatever. Okay, and then what? And then you move to memory from A, and you move to A from D. Then you increment H once again, and you move to memory from A. Right, so it's just storing, right, all these four commands, they're just storing the least significant bits into the original memory, and then incrementing it in the next thing, they're storing the more significant bits, right? And then halt. Right, that's the program. And 3500, that's where everything starts. So just to check if this actually works for like actual binary coded numbers, let me put something crazy in there. So think about it, maybe something like something that shouldn't be binary coded. If I put that, then I think it knows how to do that. So let's just put something like 19. And in this thing, I can put 19 as well. So if these were just decimals, then adding them up would just give us, like, that would give us 38. So 38 is also the same thing, like 38. No, wait, 13 in decimal, that's different in hexadecimal. In hexadecimal, that would be different, right? It would be 32 plus 32 plus 6, and that would be 2 6. That's what it should be. Okay, that's what it should be. Let's see if it is 2 6 really. I believe it's not. So it's 38 as we expected. Wait, what? Oh wait, yeah, you converted to that. Why is this 38? Look, they first did 9. Oh, this is not good. How is this supposed to even be correct? Because 19 plus 19 in decimal, that would give us 38. Okay, I get how they got 38 if your original number was 30 in decimal, right? In hexadecimal it was 26, but then this thing DA converted it to 38, right? But 19 plus 19 in hexadecimal, that gives a different thing. That gives 2 and 18. 18 is 16 plus 2, right? So that 1 goes there and makes it 32. That's what you should have got, 32, right? 32 basically. And then the conversion of 32 into decimal. Wait, what? Right, converting 32 into decimal. That would be a different thing, right? That would be very different than converting 38. So it should have been 32. Why is this 38? Let's just look what they did. DAA. Look, they just added this to M and stuff, but your DA command only comes over here. So how is it that even when you add this up, it somehow magically converts it? This doesn't make sense. Okay, you know what? I'm just gonna run something for an experiment. Let's see if DA works the way I think it does. So we just jump to start, and I will put start over here. And do nothing, because why not? Okay, and I just want to see if this works the way I want. Like, I'm going to set accumulator as something. So we'll say move immediate into accumulator. Something let's just say 32. Okay, cool. And then we'll say DAA, and after that we'll store. So we'll store accumulator into this location once again. 300 what 350 3502, right? That's what we will do. Let's see what this does. Expected, oh sorry, it should be H, and this should also be H. But 3 form, what's this? I don't know what that is. Once again, just gonna compile this. What is your problem? I'm just moving some data into accumulator. Shouldn't it be happening? Okay, I didn't put the comma in there. That's why it went wrong. Once again, what's going wrong? Oh, I didn't halt this. Oops. First of all, STA. What is this? Expected this, but that found. I don't know what you mean by that, really. So, store. This should be working. This should be working. Why is this not working? I'm pretty sure that's how it should work. Okay, this is getting bad. I know it should work like that, but they are saying it doesn't work. Just gonna do this once again. Oh, it worked now. What was going wrong? I have no idea. Okay, I'm just gonna run this and we'll see what happens. Okay, it should first of all halt. So HLT. Now we'll run this. Infinite loop in your code. Did you forget the halt? No, I didn't. What's the problem? Why do you think I forgot it? Something's just wrong about this. Stop, compile once again, and do this. Okay. So it's still 38. Wait, what? That cannot be. Compile, go step by step. So jump to start. Okay. And now it moves immediate to A32. A becomes 32 as you can see. Alright. Then it does DAA and it becomes 38. 32 becomes 30. Wait, what? 32 becomes 38. Well, 30. Yeah, that should happen in fact. Yes, that's very correct. Wait, what? But if 32 becomes 38, then 19 plus 19, which in hexadecimal would become, yeah, 32. That would become 30. Okay, that makes sense now. So these are being added in hexadecimal and these are representing binary coded decimals. This is kind of weird, but that's how it works. So we add it as if it was like that, but wow, this is not how it's supposed to be. It was 32. How can that be 38? Like 32 is 3 times 16, which is 48, but 48 is like 40 plus 8. 40 plus 8 plus 2, that's 50. So it should be 50, but it's not 50, it's something else. And that means DAA doesn't work like that. It doesn't convert from hexadecimal to decimal. No, it does something different. It converts differently. I have no idea how it does that, but yeah. It converts 30 to 38. How is that supposed to happen? I have no idea how DAA works, but if it works, then I'm gonna use it because I need to pass this. Okay, next. Okay, next thing. In fact, not next. I'm gonna retry that loop addition thing. So add all of the numbers from 2001 and onwards, where how many numbers you have to add is given in 200h. 000h. Yeah. Maybe I should try doing it once again, but this time with the carries and everything, right? Because they want to store the result at 2500, the significant bit of the result, sorry, least significant bit at 2500, and then from that onwards, store the higher bits, higher bytes. Sorry. So let's try it once again. So yeah, we'll just start with loading everything. The block of data is stored from location 2001 and onwards. How many of them? For that you store this thing. So load immediate h 2000 h. Right, whatever is in there, just want to move to some kind of variable. So move register b from memory. Okay, and then we'll increment this, but we'll keep that for later. That's our counter. And what do you want? Just want to, yeah, some of the data stored, just want that. So we'll just set the accumulator to be 0, and we'll also set the some other thing, say c to be 0. So All right. So this, instead of saying D, I'll just use C because I like that more. So this C, it will store all of the carries, and A, that's our computer, of course. So let's start. Now what do I want to do? We should start adding. So for that, we'll need to set up a loop. Our first step in our loop will be incrementing h. Then after that, we will add whatever is in h to the accumulator. So add from memory. Then you will have some kind of carry and stuff. So if there's no carry, then I just want you to jump to some other command, right? What do I call this command? Call this thing J. No idea what to call it. And what is this command really? I'll just say it's knob. Okay. Oh no, not once again. Why do they people do? Now what do I do? Like, whatever. Control Z. Right, that's better. Okay, so what is I doing? Right, if there is carry, then I want to increment D. So I and R, not D. I'll increment C because that's what I'm using for our carries. Right, instead of saying knob, let's just choose something sensible. What happens when you go to the next step? So now you have whatever is in the result in the accumulator, and now you need to go back to the loop statement, I think. Right. So before doing this, we'll just decrement our counter variable, which is B, and on not 0, so jump not 0, will jump to our loop's first statement, and this will keep on happening, right? And then what? And then we report whatever is in the accumulator to what location? Okay, 2500. Just want to store it that. So store a. Instead of doing this, maybe you should, okay, just move it like that's like LXI H 2500H. Okay, then move accumulator to move to memory from accumulator, then increment H, and then move to memory from C, and then Alt. Hopefully this will work. Let's try it out. So 2000, right? There's nothing, absolutely nothing in here. So I just want, say, 3 of these. Okay. And over here we'll say it's 98, 98, whatever. Some random value, it's gonna be C0, and let's say it's 66. So it's only 3, and that's why I'm gonna do this like that. Cool. And ready, set, go. Right. Yeah, that's fine. And let's see what happened to 2500. Look, BE01. Cool. I think that's how it should be, right? Something over here, something over here. Okay. Now let's go to the next question. Hex number is stored at some location. Write assembly. Okay, 300. Write assembly language program to intercept. Okay, this I already did in last video. Not gonna do it. Okay, next we have write a program in assembly language to shift a 16-bit number. 16-bit number. Yeah, 2 bytes. No big deal. No, wait, not 2 bytes. It's 16-bit. That's yeah, like 2 bytes is a big deal because okay, fine, it's like a registered pair or something. Numbers stored in memory location C00 and C001 to left by 2 bits and store the result in C002 and oh okay. I understand what is supposed to happen. Oh, this is weird. So how would we do this thing? Like, come on, think of it. I think I know a way of it. Okay, so we'll just start with one shift instead of having 2 shifts, and then we'll just loop that. So yeah, let's try to do it. So what's the location once again? Location C000. Okay. So this is C000. Yeah. And let's start with first of all getting it into accumulator. So we'll move from memory. Sorry, we'll move to the accumulator from memory. All right, and now we need to rotate this. So we'll rotate what left, I think. Left, rotate left using carry by okay, yeah, and yeah, that's the whole command. Okay, cool. Now we are rotated. The carry is containing the last digit. That's the 2 power 0 digit. It was in the carry, now it's in the 2 power 0 digit as well, right? We'll be using that, so we need to store that somewhere. So we'll move. Oh wait, how do we store that carry? And yeah, like single bit. How can I store a single bit into that? This is weird. Hey, it's just single bit. That means it's like 1 or 0. Oh, it isn't that bad, in fact. Right, it's not that bad. So if you don't have any carry, right, it's not 1, so the last digit is not 1, then I want to jump to just say call this thing skip 2. Yeah, and it's like skip 2. For now I'll just put NOP because no idea what we're gonna do next. Right, and what are we skipping? We are skipping if this was 0. No, wait. Oh, in different conditions, you want to put different thing. Oh, then it should be like jump on non-carry. It would be that. Ah, okay, fine. No big deal. It's nice. It's nice. So we'll just set our something called this name B. We'll say that B is 0 0. Is this gonna work? I have no idea. Come on, think. You just need some kind of like carry mechanism, but then for that using a whole register, that's kind of a problematic thing, you know. Like, do you wanna really do that? No, no, I don't. Oh, huh. Now, how do I do that? Uh, won't think of it. Yeah, you need to store that carry somewhere. 'Cause otherwise, it's not gonna make sense. Like, how can I carry that while also shifting that? So you have to use register. Otherwise, it won't work. So kind of switch something, right? So you just have to use this. Mhm. Okay. So on not carry, you don't actually have to worry about a single thing. Oh wait, not carry, that's a zero. And anyway, it's a zero. So yeah, we'll just say move image b 01h, right? So nothing so complicated till now. Okay, and now in B you have the carry basically after all of this. Once this thing is done, we can go to the next one. So we'll just loop this once again, I think. Oh, huh. No, that's not how it should be. You already looped it like that, and just actually increment. Don't loop it directly. First, just do it 2 times, and then you will loop it. So you increment h, and what that does is it makes it like C00. What is I doing once again? It makes it C001. Now in there, I wanna rotate it once again. Wow, this is very complicated, you know. Okay, once again, gonna move this to A. Gonna do pretty much the same stuff, like, but now since you have this carry, yeah. So what you can do is just rotate this. So ALC once again, and now the carry that you have, you can put that carry into that. Okay, but before doing that, you just need to put whatever is in this thing into that. Oh, this is getting complicated. No, this is not nice. This isn't nice at all. How do I do this? How do I do this? How do I insert whatever we carried into this its unit digit? It like it's a problematic thing. How do you do that? We could try to make the last digit become 0. So by taking that AND thing over here. Right. Right. And then put that thing that we carried into it. Maybe that could work. Oh, come on. Uh, come on, think. Or you could just think on it being an or something or like that. It should have been. Fine. We'll just do it. So we'll say an immediate. With the accumulator you just have, so it's like 1 1 1 all the way, but there's not that zero over there, so it's like F and E E H. Yeah, right. The last digit that will now be zero. Now to that we can add whatever we took in B. So add B like that. Hopefully this makes sense. Okay, so now you have that carry that you previously had into this thing, and your carry is still set and stuff. So jump not carry. If there was no carry, then you could, oh come on, this is getting bad. Okay, before doing that we should also probably make that oh, you could also use OR to do that, and delete it somehow. Okay, whatever, we're just gonna do the same thing that I did before. Alright, so move immediate B00. Actually, instead of saying all of this, you can just say that, but yeah. Instead of saying this, you can just say increment B. So increment register B, like this. Yeah. Okay, so control C. And over here too, I'm just gonna do that. Control V. So let's call this thing skip to 1. So we skip to 2. I know it's getting like too complicated. It shouldn't be that complicated, but this is all I could ever like think of. So yeah. We also need this thing. So skip to 2. No. Yeah. And now what? Now that we have done carrying that thing into this, okay. Now B represents whatever that you carried before, and let's just do it once again. This is why is this so complicated? Yeah, like why is this so complicated? I have no idea. I just have no idea why it's just that complicated. So now we'll decrement H, and we will no, wait, that's already done. You don't want to do that. Instead, come on, you already put that carry in it, and now for the previous thing you actually do have to put in accumulator. Hey, did we actually store what was in the accumulator? Oh no, we didn't. Right, we didn't. Oh no. Okay, this is all of it is getting too complicated. Like you move this to accumulator, then you shifted, and all of this stuff, it was just so that you can carry whatever you actually had into B. Okay, and then you incremented H directly and moved it to that. But before doing that, you should have probably done this. Move back. So yeah, from the accumulator move back to M. then you increment h, and then you move and you do this thing. Okay. Hmm. Okay, wait a second. If this is the only code that we are actually going to do that once again, like, yeah, this is all the code that you're gonna do once again. So like move a, m, and r, and c, that stuff. Oh god. Right. Wow, this is such a simple task, and yet it's like taking so much of time. Okay, so you move to a kilometer from m once again, then rotate, then same thing. You just, oh no, this is a new code. This is a little bit of new line. So you make that last thing become 0 and you add b to it. Okay. All right. Fine. Right, and then you do this thing. You once again just put whatever was into b. Once again, now you have everything in b. Next, what you want to do is just want that to be on the first guy's units digit. Right, so we'll have to do the same thing as this. Like move that to the, oh no, this is getting bad. This is not systematic at all, and it's like just the worst. Wish there was some other way to do this. Like, come on, there must be some other way to do this. What if we rotate both of them first, and for the second guy's unit place we take that? Oh yeah, so like we rotate the first guy first and second guy second, and then using that carry we push it into the first place. uh, that is still complicated because we will lose the information of whether or not the first guy's second place was what it was, and that would not be good. So something else. I just want this to become like a loop or something, but then it's just delete all of this, just delete all of this, and we'll start from new. Okay, so all of this much of code, what we are doing with it is just we are moving from memory to a, then we are rotating it, and then we are, oh yeah, cool. So we're storing in b, but then b is also somewhat like the carry thing, right? That's not a good thing. That's not a good thing at all. So yeah, like you move that in there. You need that carry later on. That's the whole reason that we are doing that. But if you had incremented h, then later on you want to decrement it, and all it does is that it's just that it moves, and then whatever was in the carry, it moves that into b as well. Right. It's not that bad, I think. It's not that bad. Or is it? Oh, seriously. Okay, fine. We'll just make this into a function then, right? Just make this into a function. So this will be our start, right? F start, or let me just call this thing call, CALL, and we'll have that return over there. And yeah, how do you actually have a return? Oh no, there was something that could make you return, right? And that was in stack and stuff, and that's actually kind of problematic because like, oh no, it's not gonna work. Stack in action, return statement. Yeah, so you can call and then you can return. Uh, should I use this? Maybe I should because yeah, I really do wanna use this. I will have to use this. So call and return. Just read what all of this is because I'm going to be using this. That's the only way to actually have all of that code written correctly. Or else I'm going to have to write the code 2-3 times. And that's not something I want to do. Okay. I hope you're done. Now let's do it. Let's do it. So this will be our call, and then we'll just say RET. Oh yeah, this is not gonna work because call is actually a keyword. So let's call this thing F. Right. So we'll say that this is just the return statement over here. Right. So this function, what does it do? It moves whatever is in memory to A, then it uh, rotates it. It puts the carry thing into B. Okay. Then it returns like that. It also moves whatever is in accumulator to the memory, and then it returns. Cool. And now we can use this function to do a lot of things. Okay, so let's start. First, what we need to do is just apply this function on the first guy. So this thing, we'll just say control C data, control V, right? Now we can call this function. So call F, right? What it will do is do all of this, and then it will return some kind of B to us. Okay. Now we know what is in our B value, right? Next, we want to use this B value to actually do some stuff with that guy. Yeah. Oh wait. Hmm. That's not nice. Uh-oh. Because before doing that, we also want to do, okay, wait. You have this B value, and where do you want to put this? You wanna, oh, so this will actually put the B value back to what it was. This is not nice at all. This doesn't make sense. This function actually once again just works like a carry thing. So it's just that B and carry both are the same, but they are like still going to be overwritten, and that's not nice. So instead of using this B thing, we actually have to like, yeah, like store the carry somewhere. Oh no. Uh this is bad. This is really bad. So we will just have to kill all of this. So if there's carry, what we want to do is, yeah, so just want to say increment So now increment h, not once but many times actually. So instead of saying that, I should probably say like increment L only, right? I just want to increase h by a certain number like that. That probably makes sense. It's definitely not going to make sense. How can you create a function like this? Okay, I think this is enough. I should probably stop now. Okay, I'll see you guys in the next video.